Improving disaster response with intelligent collaborative agents. When considering the development of a smart future, it becomes important to consider how to react and respond to disasters. As it stands today, disaster response is completed by responders willing to risk lives to help affected communities. These current response methods rely heavily on a large number of responders to mount effective responses. Because of this, it becomes increasingly difficult to respond rapidly and help everyone in need. Current response methods rely on responders being placed into dangerous situations, and ultimately, risking the lives of responders should be avoided whenever possible. One very applicable disaster that affects Wisconsinites on a regular basis is the flooding that occurs due to severe weather conditions. The devastation caused by these meteorological events has been increasing in intensity and has most recently caused floods to occur. On average, this occurs once every 2 weeks over the course of a year. According to the Wisconsin Emergency Management Division, flood damage is the most widespread disaster across the state. In the summer of 2018, a state of emergency was declared due to weather conditions that flooded much of the state, and an estimated $200 million in property damage was caused. Because of the devastation caused by these disasters, preparing for severe weather and responding to floods remains a priority for Wisconsin government, citizens, and businesses. In the future, a new disaster response system is needed to improve the assistance provided to those affected, while keeping disaster responders out of harm's way. The proposed disaster response system involves deploying intelligent collaborative agents to allow for a faster and more effective response to disasters. In the severe flooding example, intelligent collaborative agents can be deployed to provide immediate assistance for those in need. This simple concept will be achieved through the use of advanced collaborative decision-making systems, and together within a network of unmanned aerial vehicles, they will be able to operate as IoT devices and use aerial visual processing at the edge of computation to provide the framework with localized environmental data. This disaster response system is capable to being applied to many different disaster situations. It can be tailored to what the disaster needs and what the response is necessary for that particular environment and disaster. The disaster response framework is currently in development and is composed of 2 classes of agents that are used to observe the environment and complete response objectives. The first class of agents, known as observational agents, will primarily be composed of UAVs and will be responsible for collaboratively acquiring and analyzing localized aerial footage. Onboard aerial visual processing systems will perform edge analytics of aerial footage to provide disaster responders and other agents with access to the current state of the dynamic environment. The other class of agents, known as executive agents, will have capabilities tailored to the disaster at hand and work collaboratively with each other to achieve assigned objectives. These agents will be individually tasked with autonomously completing response objectives and assisting disaster responders. Executive agents will be able to navigate independently using visual and sensory data that is analyzed at the edge. This data will also be accessible to the rest of the framework to provide a deeper understanding of the environment. The most critical tasks that executive agents will be assisting in is life-saving search and rescue missions. By assisting in these tasks, the number of responders needed for each mission is decreased, and the number of rescues performed will be increased as a result. This framework will ultimately change the way our society reacts to disasters, and hopefully, this will lead us into a smart future.